Hi Logan, I've seen your message. I can see that you're asking for 1 EFGHIJ and then pretty much all of question 2. So that's most of the sheet. So let's do this together. What I'll need you to do is in your notes, I want you to have a page where you can see all of the formulas. Okay, so in our own OneNote book, in measurement, remember there's a tab that's called revision. I've got all the formulas sitting here that we revised together. I want you to have that ready, or at least copy that onto a page so that you can identify what shapes you can see, and then you're using the formulas in it to solve. Okay, so a lot of the questions that I'm seeing there is area of a rectangle, area of a triangle, then you might have some area of a trapezium. Okay, so as long as you've got those formulas ready, then these questions will make a bit more sense, especially with circles as well. Yeah. So let's have a look at your sheet again. I'm just going to go back to, I made it in this sheet, didn't I? All right, here we go. Let's do E. E, F, G, and H all follow the same thing. So you need to be able to picture two different shapes, or break this overall shape. Okay, so you got this sort of house-looking shape into shapes that you are familiar with. So for me, I can see that you've got a rectangle. Can you see this rectangle here? We're going to try to find the area of just the rectangle, which I'm going to color in yellow. So how do you find the area of a rectangle? See, so I want you to go through your notes. What's the area of a rectangle? So I'm going to give you a moment to think. Go through your notes. What is the area of a rectangle? And hopefully in your notes you should have length times width. Okay, so this is the area of a rectangle. So to find the area of this rectangle here, well, that's simply the length multiplied to the width. So the length is 4.5 and the width is 2.4. So I know that this area here, just this space here, is 4.5 times 2.4, and that should give me the area that I've outlined in purple. Okay, so in your calculator, I'm going to get my calculator up. 4.5 times 2.4, and I get 10.8. Okay, so this is 10.8 square meters. That's the area for that region. Then I still need to find the area of this shape. See, look at this shape here. I'm going to draw it in green. So you need to ask yourself, what shape is that? Can you see how I cut it up and I can see two shapes there? What shape is that? So the one in green, if I draw it again, what shape would you call this shape? Okay, it's got three sides. So go through your notes, have a think. Which one of those shapes do you have? Once you've got the, shape in mind, what is the area formula? So again, area, and this, hopefully you picked up that was a triangle. So the area of a triangle, we have half times base times height. Now, in case you don't know what base and height is of a triangle, base is any length, normally on the bottom, doesn't have to be the bottom. And then the height is always perpendicular, meaning 90 degrees to that base. Okay, so that's how I taught it in class. That no matter how the shape looks, you're always picking the one that's 90 degrees to it. So this is your formula, half times the base times the height. Okay, so when I go back to my diagram again, can you see how you have this triangle that looks like this? So what is my base? Base must be the length from here to here. So the question is, what is that length? Can you see that? So I'm going to rub this out. See if you can see the length. I'm trying to find the length from here to here. What is that length? Yeah, because that base is here. So I'm asking you, what is the base in this diagram? So if you can see it in that triangle, hopefully you can see that this is your base. See, that's your base. But then what is that base equal to? What is that length? What is the length from here to here? And hopefully you can see that it's actually the same as this rectangle. So it must be 4.5. Okay, so my triangle, the base now tells me it's 4.5. So again, what's the formula for the triangle again? Area equals half times base times height, right? So I got half times, what's the base? We now know it's 4.5. But what is the height? See, the height has to be perpendicular to that. And in the diagram, can you see what the height is? Have a look at the diagram again. So look at this diagram. We've got now the base here is 4.5. What is the height? And if you can see that the height is 90 degrees with it, it is 1 meter. So that means that it has to be times 1. Okay, so that will give you the area of the triangle. You already found the area of the rectangle here. So together, the area of the rectangle, which was 10.8 square meters, you need to figure out what this is on your calculator, the area of the triangle. So what's the area of a triangle? Let's go back to our calculator, sorry, it was half. So type in half. If you can't type in the fraction, do bracket 1 divided by 2, close brackets, whoops, like that, times, what was it again, 4.5 times 1. Okay, so if you type that on your white calculator, bracket 1 divide 2, close bracket, times 4.5 times 1. Oh, sorry, because I'm using my year 12 calculator. It's 2.25. Okay, so the area here is 2.25. But together, we want to know the total area. So it has to be then 10.8, which is what we had before, plus 2.25 gives us a total of 13.05. Okay, so the total area is 13.05 square meters. Okay, and that's in your, you can check your solutions at the end of your sheet. You can see that, which one is it? There we go, 13.05 square meters. Okay, so in the next 3 questions is actually the same. So can you see how I can split this into a triangle? See, that's a triangle. So you got the base of the triangle is 80, but you need to know what the height is from here to here. True? So how would you find that out? What is that height? So you're trying to find from here to here. What you do know is that from the very top to the very bottom is 70 centimeters. And then you know that from here to here is only 30. So what's the leftover to make it 70? See, if this is 30, then how much more do you need to make 70? True? So that means that this height has to be 40. See, 30 here, 40 there. Together, you get 70. So if you know the height is 40 now, so the height is 40, you can then find the area of this triangle using what we've just done before. So again, area of a triangle. What is that again? Check your notes. Don't copy me. I want you to look and think. So half times base times height. What's my base? What's my height? You fill it out. Okay, half times what and times what? Figure it out. That's the area of a triangle. And then what are you missing now? You need to find the area of the rectangle as well. This is the area of the rectangle. But I'm assuming at this point you know how to find the area of a rectangle. Okay, length times width. Add them 2 together and you get your answer. So you can see that in E and F, that's pretty much the same. And then I'm going to leave G for you to do because it's the same concept. Try to find that triangle. So I can see triangle and you got your rectangle. See, it's all about trying to pick out what shapes you know. Okay, see if you can find that again. So here's the base. Try to figure out the height. Once you can, you've got the triangle, you've got the rectangle. I want you to have a go with that yourself. Okay. H, same thing. Do you see a shape that you can change into, cut this shape so that you can use basic shapes? See if you, I'm going to give you a moment, have a think, because in the next second I'm going to show you. Can you see it? Okay, if you can't, can you see if I just cut this one down, I get 2 different shapes. One's a triangle and the other is a rectangle. Okay, rectangle, I know that you know how to find. So it's 3 times the 2 gives you the area of the rectangle. 3 times 2. Now this triangle, this is probably what students generally find tricky. And it's not that tricky because, again, remember how I said you just need to multiply base and height, right? Doesn't matter which one's base and which one's height. You just need to make sure they are 90 degrees with each other. So I just need to know this length because it's 90 degrees with this length. Can you find that length? Okay, so have a think. I'm going to rub this out. Okay, I want to know what it is from here to here. You know the entire length is 6, and you know that from here to here is 3. So how much is here? Figure it out. Once you can, then you've now got the base. So remember, area of a triangle is half times, go through your notes, base times height. Okay, so it doesn't matter which one's base and which one's height, as long as they're 90 degrees with each other, yeah? Then the next thing you need to find is, well, how far is it from here to here? Now, logically, you know that from here to here is 3.5, and you also know from here to here is 2. So how do you find the total length? See what I mean? Then once you've got that, you now have yourself a height and a base, and you can figure out the formula to find the area of a triangle and the area of a rectangle. So G and H, E and F are all the same idea, triangle and a rectangle. I want you to have a go with those two, okay? Or technically you can do F as well, because I haven't really fully answered it for you there. So E, F, G, H you should be able to do. What about here now? I. Hopefully you can see two shapes. Now this one is a rectangle. So most students will be able to pick out the rectangle. Great. It's 32 times the 12 will give you the area of the rectangle. But what shape is the other one? What shape? So you need to go through your notes and see what shape is this four-sided shape. Go through your notes because there is a shape. Okay, I'm going to pause here just for you to think before I tell you the answer. If you still don't know, this is a trapezium. Okay, so remember in your notes, got to go back to all your notes. I'm going to go back to the year 8 maths again. You got to look at your notes and draw the diagrams. Yeah, so look at the trapezium. It's this one, isn't it? Because I'm just tilting it on the side. So it just looks like this, like that. But technically that is a trapezium. And how do you know? It looks like there's two parallel lines and the other two are not parallel. That's how you know it's a trapezium. Okay, so it's a four-sided shape. It's not a kite. It's not a rhombus. It's not a parallelogram. It's clearly a trapezium. And what's the formula for a trapezium? Right here. Half times A plus B times height. What is A and B? These are the two parallel lines. A and B are the parallel lines. H, which is the height, is the distance between the two, and it's 90 degrees with each other. Okay, so in this case here, this could be A and this could be B, and the height is how far it is from each other. Okay, so I'm going to go back to our own diagram again. So let's go back to our sheet. Whoops, was it over here? Let's go back to our sheet. Can you see, if I draw that shape out again, it's a poorly drawn shape. Actually, I'll do it again. Can you see that this is your 10 centimeters, which is from here to here, right? And then you do know the length of here to here. What is that length? So you have a look at the diagram. That tells me if this is 32, then this must be 32 as well. True? To the other side of the rectangle, so that's 32. So these two are clearly parallel, and those two are not, right? And so now you've got A and you've got B, so this must be B or A, doesn't matter, A and B. And the formula for a trapezium is area equals half times A plus B times height, right? You got A, you got B, you're missing height. How do you find height again? Remember I said it was the perpendicular distance, so it's 90 degrees. You need to find from here to here. See what I mean? This is the 90 degrees. That's how far the two parallel lines are. So how do you find that? Have a think. Don't wait for me to tell you the answer. I want to know this length from here to here. What am I given? Look at the diagram. I've got from here to here is 26, and I know that from here is 12. How do I figure out this remaining length from here to here? Okay, hopefully you figured it out. 26 take away 12 gives me that this had to be 14. Okay, so 12 plus 14 will give you a total of 26. So that means the height from here has to also be 14. Okay, so now that I know that this is 14, I can use my formula. It is equal to half times 10 plus 32. Doesn't matter which one's A or B. And then you're timesing this to the height, which is 14. Make sure to do the brackets first if you're doing this on a calculator. Do the brackets, times by 14, and then times by half, or divided by 2. Okay, So that's how you do I. How do you do J? J, again, can you see two shapes? It's all about trying to see the shapes, yeah? Hopefully you can see the rectangle. Rectangle is always the easiest one. That's 30. 30 by 10. 30 times 10, length times width. So that's easy, right? 30 times 10, that's easy to find. But can you see that from here to here is also 30? Now that other shape, what shape is this that I'm coloring in green, that I'm outlining? What shape is this? And hopefully you can tell that this is a semicircle. So this is the center, and we know that 30 centimeters tells me from here to here. So how do you find the area of a circle? Go through your notes. I want to pause here. You should pause my video too and think. See, I want you to think. I don't want you to follow what I'm telling you. I want you to think. What is the area formula for a circle? Okay, hopefully you got it. If you haven't, pause it. Area for a circle should be pi times radius squared. Now, that's the formula for a full circle. So as long as you know what the radius is, then that formula will give you the area of a full circle, right? But I don't want the area of a full circle. I only want half of it. So how do I find half of the area? What do I have to do? What's the formula to find just half? So if you want half, you have to divide the whole thing by 2. True? Because that will give you half of the circle. Well, what is the radius then? See, in terms of my diagram, all I have is that from here to here was what? We knew that from one edge to the next edge was 30 centimeters. Can you see that? From one edge to the next edge. If I just dotted it, can you see this is the full circle? And I've got the diameter. But I want to know the radius, which is only from here to here. What's the radius? Have a think. Hopefully you figured it out and said R should be 15. Okay, so radius should be 15. Well, that means you've now got a formula for the semicircle, and that should be pi times radius, which is 15 squared, divided by 2. Okay, you divide it by 2 because you want half of it. You only want half the circle, half the area. Cool? So that will give you the area of half the circle. So area is equal to pi times 15 squared divided by 2. But don't forget to add with the area of the rectangle, which is 30 times 10. Okay, so that's how you would do I and J. But can you see that E, F, G, H, I, J, I'm just really using all the formulas that I've given you. Triangle, trapezium, half a circle, all of those you have to remember or at least use, okay? And then on your question 2 here, you're trying to find, if I imagine this, if I just told you to find the area of this shape, right? Just fully this shape here. How would you find the area of that? That's a square, true? If I asked you just to find the area of that, you would have told me area of a square is length times length, which is 9 times 9, and you just said 81. True? But I don't want the full area. I want to have the area minus the circle in between. True? You don't want this section. The green section you don't want. You just want the purple section now minus the green. So how do you do that? Well, you literally do it. You literally find the area of the entire shape. So paint the whole entire thing, okay, and that would have been 81. That's the area of the entire shape. And then you cut out the circle. Cut that one out. True? Find the total area, and then minus the circle area. Then you're left with what you want. True? So total area we know is 81, but how do you find the area of a circle? Go through your notes. Pi times radius squared. What's my radius? Look at the diagram. What's the radius in this circle here? So this is my circle. Think about it. What's the radius? And hopefully you figured it out. It should be 3 squared. So type in your calculator now. You want the area of the square, take away the area of the circle, and that will give you what you want. So in my calculator, if I did it in front of you just so you can see, area of a square was 9 times 9, true? And then you want to minus away that circle because you found the full area, but we don't want that circle area. So we need to remove that circle area. And that circle area was found by pi whoops, where's pi? Pi times 3 squared. See that? So 9 times 9. I'll put it in brackets so you can see. 9 times 9 is that's the area of the square. And then pi times 3 squared is the area of a circle. So area of a square, take away the area of a circle, will give you what you want. And that gives me an answer of 52.7257. Yeah, so if you look at the answers for 2A, where's question 2A? See that? 52.73 squared centimeters. Okay, so same idea. So each one, you're trying to see how can I manipulate the shapes so that I get the area I want. So same thing with this one. What two shapes can you see? Hopefully you can see a parallelogram. See, that's a parallelogram, not a rhombus. Okay, that's why, how do I know it's not a rhombus? A rhombus has to have all the sides the same. It's like a square tilted. A parallelogram is a rectangle tilted. Okay, and how do I know it's not the same sides? Notice that this is 18 and this is 22 already. So I already see that they're not the same, and there's no dashes as well. So what is the area formula for a parallelogram? Go through your notes, have a look. Again, it's all on this page. You got to go back to my 8 revision sheet. Let's go. Let's find my parallelogram. Where is it? Here we go. Parallelogram. This is a parallelogram over here. And what's the area? Height times base. This is my height. And then this is my base right here. That's the base. True? So you're just simply using the formulas that I have told you to copy down a while ago. Make sure you have it in front of you. That's what I want you to have. Okay? So we go back to the same problem again. Let's see, can you see? You need to find the area of the parallelogram. So we're going to find the full area of a parallelogram. So just imagine you paint the entire area. But you see, you don't want the entire area. What don't you want to include? You don't want to include the circle. This was the region you don't want. So you need to find the area of the circle and minus it away from the area of the parallelogram. So again, area of parallelogram is base times height. You need to minus then the area of a circle, AC. What's the area of a circle formula? Pi times radius squared. So if you fill it all in now, can you see area of parallelogram base was 18 times by the perpendicular height. It's always times it by the perpendicular height. See, that's 90 degrees there. So 18 by 22. Do that on your calculator. You can do it all in one go as well. So 18 times 22, put a brackets around it. Minus, what's the area of a circle? Well, this is your circle here. Can you see this is your circle? I'm going to slow down a bit. I want you to do it, yeah, not me. Because I know how to do it. I want you to know how to do it. So this is a circle. How do you find the area of the circle? Go. Think about it. What's my radius? Fill it out. So this should be pi times 8 squared. Type that in your calculator. Okay, so I'm going to type on my calculator so you can see. Here we go. Let's look at it again. You should be bracket 18 times 22, close bracket, minus pi, pi times 8 squared, because 8 was my radius. See, I typed it all in one go. True? Can you see that? Can you see how I typed it all in one go? This is the area. This is the area for the parallelogram, and then this is the area for the circle. And I'm minusing it because I don't want the circle. So I press enter, and that gives me 194.93. You see that? That's how 2b is 194.94, because you got to round to 2 decimal places. Okay? All right, let's have a look. So same thing. What I want you to do this one now. So I'm not going to do this for you. I want you to identify the two shapes. Have a think. You clearly don't want this circle. So you need to find the area of a circle. What's the other shape? Have a think. Can you see the other shape? Pause it, because I'm going to tell you the answer now. This is a triangle. Can you see that? If I can find the full area of a triangle and then I minus it away, minus the circle away, then I get the leftover, which is what I want. So you need to find the area of the circle and you need to find the area of the full triangle. So formula for area of a triangle, go back to your notes. Half times base times height. Area of a circle is pi times radius squared. And you're going to find, once you know the answers for that, you're going to do area of triangle, take away area of a circle. Why? Why do you do that? Because area of a triangle, you get the full area. You get everything you want. True? But then you don't want that circle bit, so you're going to try to remove this area. That's why it's area of a triangle minus area of a circle. Okay? Can you see the same thing for this one? Do you see two shapes? Have a think. Pause. Have a go. And now I'll tell you the answer. Again, same thing. Find the area of a rectangle. You get the full area. Get the full area. And then what are you minusing? What are you removing? Hopefully you figured out that you had to remove the area of a triangle. Okay, so rectangle, area of rectangle minus area of triangle is how you find the answer. Have a go with that. See if you're getting the right answers. This one. This one's a bit trickier, okay? But same idea. Can you see this is a square? So you can find the full area. So this is the entire area. How do you find the area of a square? What's the area of a square? This is 40, and that's 40, not 30. Don't confuse it. Look at the diagram carefully. It's 40 by 40, so it should be 40 times 40. That gives you a full area. Now, in the full area, you want to remove this semicircle. Yeah? And notice it's 30 centimeters wide. So if I draw the semicircle, this is 30 centimeters wide. How do you find the area of a semicircle if you know that this point to this point is 30? Do you have the radius? Is 30 the radius? Think about it. No. If you said yes, then it's wrong. It's not 30. Okay, the radius is not 30 because remember, in a full circle, radius is only from the center out, right? Whereas in this one, you've got half a circle and it's from one point to the next point. From this point to this point, it's already 30. Yeah? A radius is from the center out. So that means this has to be 15 and this has to be 15. So radius is 15, diameter is 30. So now you know the radius is meant to be 15. How do you find the area of half a circle again? Go back to your notes. You got to practice this. Okay? Then once you know that, you can then find the area of the circle, or it's half a circle. Hopefully you knew it was pi times radius squared divided by 2. You need to do the same thing for this one. Area of a circle, pi times radius squared divided by 2, because that gives you another half circle and radius, diameter 30. Okay, and so once you know the areas of the circle, remember, you're going to take the area of the square, and you're going to minus the area of half the circle, and minus again the area of half the circle. Okay, I'm going to pause there for you to think about what I just said. And then lastly, can you figure out the same thing? This one's probably the trickiest one, but it's the same idea. You only want this section of the graph. Can you see the shapes? See, I see two shapes. I see one, you get a full rectangle. See, this is a nice rectangle, isn't it? So that's 4. So here's 4 as well. But my question is, what is the length of this rectangle? Have a think. Can you see it? Because I'm going to rub this out. Can you see the length? See, it's a bit hard, isn't it? This is 4. Now, for those who are sort of have a good eye to this, note this is 4 as well. True? This is 4 as well. True? This is 4 as well. True? Now, why is that important? Because remember I said the radius is from the center to anywhere on the circle. True? So that means that from the center out to this point, it also has to be 4 because the radius must be 4. True? So here it must be 4, here must be 4, here must be 4, here must be 4, and here must be 4. So when you add them all together, what is the length? The length should be 4 plus 4 is 8, 8 plus 8 again is 16, 16 plus 8 again is 24. So I know from here to here is 24. Okay? Now that you know that is 24, you can find the area of the full rectangle. True? You got the area of the full rectangle, but what do you want to remove? Have a think. You want to remove this half circle away from it. You want to remove this part. You want to remove this half circle again. And you want to remove this half circle again. How do you find the area of half a circle? Go through your notes. We just did it before, just like a few examples just now. Radius is 4. See, the radius is 4. So it should be pi times 4 squared. That gives you a full circle, but you want half, so you got to divide it by 2. True? And you got to do the same for this one. And you got to do the same for this one as well. So you got 3 of them. See, so you should have 3 of them. So you're going to find the area of the rectangle, okay, which is same thing as saying 4 times 24. All right, 4 by 24. That gives you length times width. And then once you got the area, you minus the area of the first half circle, minus the second half circle, minus the third half circle. And that should give you your final answer. Okay, so that is probably the trickiest one there. I'm pretty sure K and F are a bit trickier, but see how you go. I'm pretty sure you would have done K okay. Maybe L is one of the hardest ones in my opinion, but there was an example in our exercise that I've already done. I think if you go to our exercise on circles, area of a circle, I did do a yin-yang one. Where's the yin-yang example? I'm pretty sure I've done it already in class. Wasn't this one? Maybe it was circumference, was it? Oh, I did do something similar. Have a look at this video. So the class video for 4B. See if you can get an idea of how to do it. Okay, same technique, except you're finding the area. Instead of circumference, you're finding the area. Same idea. Okay, I hope this video helps you. It's quite a long video, but hopefully this makes more sense on what you want to do. Okay, so I gave you a lot of theory. You need to action it. Okay, good luck.